I want to continue talking about C. Hopefully people will have installed VS Code and made it work. If you haven't yet, another option is online GDB. So if you just go to onlinegdb.com, you can write C code there and just run it online. That's not as good as working with VS Code, but it will do for now. So what we had last time, so I'll run the thing locally because I can. You can also try to install this on your local machine and just run the C compiler on your local machine. The issue is that that's like on average more difficult to do than working with ECF, even though working with ECF can also be kind of annoying. So it's a trade-off. So what we had last time is just the Hello World program. So that was kind of with this. So we had printf Hello World, and we had return 0. And by the way, so there's various ways of arranging just do this, and this is a perfectly valid C program. It's just not very readable. So I'm going to try to be so you'll see all sorts of things if you read C code on GitHub or whatever. So I'm going to try to be consistent, and I'm going to try to always put the curly braces like after the header, which says the name of the function and what type of thing the function returns. So this is known as, so comments, by the way, that follows 2 double slashes is comment, two forward slashes is a comment. This is what's known as Kernighan and Ritchie style. And there's kind of various other details, but one of them is the curly brace, the next line after the function. People sometimes, which is kind of for the course. I don't think it's necessarily the introductory textbook, but it's very famous and it's kind of well known for being kind of very concise, which makes it like not necessarily the best textbook. So Brian Kernighan, currently a professor at Princeton University, a graduate from NSI in like the 1960s at some point. So he is like a local guy. So that's like that. So what we were discussing before is variable types in C. So you need to be able to. Are they talking? It's very distracting. Okay. Is it just like the lecture room next to this one? So, okay. So we'll try to get through this, although that's like a lot more annoying than people talking in class the way they do in my whole 150. So before we use a variable, need to declare it. That's very loud. Optionally can also initialize it. So initializing means assigning an initial value. So the way it goes is you give the type of the variable, then you give the name of the variable, and then if you want to initialize, you have equals whatever, and that's the initialization. You can also do something like this. So b is an integer and is not initialized. so can have any value, right? So if you try to print B afterwards, in principle, you could get any kind of output if you don't initialize. So for that reason, almost in 100% of cases, want to initialize. So the difference with Python is you need to actually, oh, they shut up, that's good. So I didn't though, so they're probably still annoying. So if you are, so you always want to say the type. So one kind of type was int. So the other kinds of types that we had on the slides before were double and car and int star and car star. So double is just the same as the Python float. That's review from last time. Car is a single character, so something like this. And then this is new. And we have to do it now because already when you're using strings, you have those types of variables. So int star is a variable that stores an address of an int. So that means it says where in the memory table is a value that happens to be an address of something that's an int. And this is the same, but for car. So this is what it would look like in the memory table. So unlike with Python, we just have the one memory table. We do not have a variable table. And we'll explain why in a second, and we'll come back to that several times. So you might have a situation that's kind of like this. So H is stored at address. It doesn't want to. So H is stored at address 1032, and then maybe I is stored at address 1033. And then this special character, this is called the null character, is stored at address 1034. So that just might be the state of the memory table. If that's the state of the memory table, you could have a value that's the address of the H somewhere else. So maybe over here, you have the value 1032. And then you can say the type of this is car star. So the type of the value that's stored at address 1036 is car star because we happen to know that we mean for it to store an address of a character. And it so happens that 1032 is over here, and at 1032 you have H, and at 1033 you have I, at 1034 you have the null. So what you can tell Python, and we're about to do that, is print me whatever is at 1032, and then at 1033, and then so on until you get to this special null character. So that's what's going to happen when I write this. So we'll do this in more detail in a second. There's several interlocking parts here, so I'll do everything and then we'll come back and reiterate everything. So this is saying that I want to print the string S1, and the string S1 is high. So if I print this, oh no. Oh, that's unfortunate. Yeah, so this error is like extremely annoying because what happened is the program was named a.c, and then I also had a folder that's called a, and that created the conflict. So I'll just go to the lectures. And I'll create the file a.c. And now it's fine. So I would go to the terminal to see what the output was, and the output is high. Okay, so far that looks like Python. So the difference is what we're doing here is I'm saying car star S1, and then I'm saying that equals high. So what this actually does, similarly to Python, is it puts high in memory. And then it stores the address of H in S1. And then when I print, what happens is I'm telling it I want to print S1. S1 is just the address of the H, and then it goes to the memory table. If S, for example, is 1032, so if this is S1, then it goes to 1032, and it just prints H, and then I, we also had an exclamation point, and then it finds the special null character, and that is when it stops. All right. So here's something that you wouldn't see in Python. I can also say I want to print S1, but I want to actually print not the string, I want to print the value of S1. So you can do it. And I'll explain how this is happening in a second, like this. So here what they printed is actually the address where the H actually lives in the memory table. That's the actual address. So it's similar to what you would see when in Python you say ID. So what printf does is when you say something like %s or something like %ld, what it does is it says, I'll interpret S1 according to what this % thing says. So %s means string. And then %d means integer. So D stands for decimal. And then %ld stands for long decimal. So this is also another, basically another type of integer. So what's happening when I say printf sn? Well, it gets this data S1. So this, in this example, would be 1032. And then it goes to, because it knows that it's a string, it interprets it as, oh, I need to go to 1032, print the character 1033, print the character 1034, print the character. Oh, now it's the null, so now I'm done. And for that reason, if you say %ss1, it prints high exclamation point. Does that make sense? So on the other hand here, you're giving printf exactly the same value, right? So printf is a function like any other function. So you're sending it as one either way. So how is it that even though you're sending it exactly the same thing, either way it prints different things depending on what the string is? Well, what it does is it goes to the memory table and interprets the memory table according to what this percent thing is telling it. So this is saying print the string S1, and then, by the way, a new line. And S1 happens to be a string, meaning it's an address of a car. And then this says print S1, and S1 is, again, the same thing that's being sent to it, which is an address, and it says, well, it's a number, print the number. Right? So does completely different things inside, because if it's a string, then it needs to go to address 1032 and go 1032, 1033, 1034. On the other hand, if it just says, like, here's the data, 1032, print it, it'll print 1032. Yes. It stores the address of the first. Well, so this is one way of saying it. Another way of saying it, and this is kind of, if you're talking about this, then yes, S1 stores the address of the H. Right? So here we are saying interpret S1 as if it happens to store the address of a sequence of characters. Here is saying, again, like in both cases, for example, S1 is 1032. It's just that printf does different things depending on whether it substitutes S1 for %s, in which case it goes to address 1032 and then finds the null, prints everything until null. Or if you give it S1 and say it's a number, it'll print the number. Yes.
What if your S1 is an integer type? Then would L be interpreted that as the
if you say %LD, that means interpret it as an integer. So it might, like, we'll get into exactly how things are represented. Wait, I'm not sharing. So we'll get into how it's represented exactly later on. But basically, it'll do its best to just go into the memory table and interpret whatever you give it as what you say it is. So you can, again, say something more complicated. So the string is %s, and then the address is %LD. And what's going to happen is this S1 gets interpreted using %s, and this S1 gets interpreted using %LD. So the usual thing is, like, if you get things right, then it works. So the usual thing would look kind of like this. So if I want to print A, I'll say the integer is, and then I'll just say D. And that's going to be like that. So if I run it, now it'll print something. Wait, the integer is, didn't save. Oh, because I already have an A somewhere. So now it says the integer is, and then 43 over here. Yeah.
So how would we retrieve the contents of this address? Like, if you want to bring that, how would we do that?
We'll see in a second. Okay. So all right, so that's like that. A very common thing. So VS Code is going to catch it if you do it. But a common thing is to basically try to use things incorrectly. So you can, for example, say the integer is, and then you say %SA. So what is it going to do? Well, it's literally going to go to address literally 43 and then try to read stuff from address 43, right? As if it were a string. So if I try to run this, and that's not going to be reproducible, it might be different anytime. In this case, it just created a segmentation fault. So segmentation fault means trying to access or modify the memory table in a way that's incorrect. So basically what is happening is here, printf is going to address like literally 43 because we said A is 43, and then trying to print the character at address 43, and then trying to print the character at address 44, and so on. 43 is too small, so the computer would probably just refuse to let it access address 43 anyways. It might be that you can access the address 43, and then it creates the problem of you keep going and looking for the null, and the null might not, well, there's no reason to expect that there would be a null there or anything else in particular. And that's just because A is not actually an address. We're just telling printf to interpret it as if it were an address. And C will not always protect you from making this kind of mistake. So in Python, of course, like this whole thing is inconceivable in the first place because you can't just say, oh, this is an address, just go to that address and get something. If you give a variable to a Python function, well, it must correspond to a value because there's just nothing else that could happen in Python. Yeah.
So it will still interpret it as an address even if it's not an int star type.
Yeah, and that's because we told it to, and because it doesn't look at the type here; it looks at the value, right? So that's kind of the game here. Is we're sending the same value twice in this case. So we're sending S1 and we're sending S1, and then it uses the value in kind of whatever ways it needs to in order to interpret it as either a %S or %LT. All right. So that's like that. So again, from the top, basically what we have is you can print a string like this, for example, and you can print an integer like this, for example. And this looks very simple, right? So it's just that you send it the string and you say %S here, and the S1 gets substituted instead of the %S. Same with an integer. The complication is that what actually happens is you give it the value, and it interprets the value according to whether it's %S or %D or whatever. And so sometimes you can do it in a useful, well, semi-useful way. You can, for example, find out where the string is actually stored. Sometimes if you mess this up, it would just crash when you try to run it because A is not actually a valid address. Yes. Yeah.
So when you write %LD on string, you get the address of the first term.
So I'm not running it on a string, right? So S1, we interpret it as a string. What S1 is the address of a character. Both, right? S1 is always yes. So here, what I'm saying is I'm putting high in memory, and then S1 is going to be the address of H, right? So it's this picture where, for example, the value of S1 is going to be 1032 because 1032 is where the H lives. Right? So it's always like that. And then printf, if it gets %S, it says, okay, I'm going to try to use this S1, which I'm substituting for S, as if it's an address of a character. Here, I'm saying I'm going to use S1 as if it's an integer. In either case, it's the same value. You're just interpreting it very differently. Yeah. So it's just that %T prints it in hexadecimal, which we're not going to do. Okay. Like the reason I'm doing it like this is because this is decimal. Yeah. Yes. Can't hear you. Well, there's no lists as such in C. There are arrays, which is a slightly different thing. The answer is yes. We'll get to that. But also the answer is actually when you're using the array, it just gets converted to an address anyway. Yes. So the reason there is a star after the car is that the value is the variable name is S1, and then the type of the variable is car star. The reason is that S1, what it does is it stores the address of an H. So the address of a car is a special type of variable. So a car is a character, right? So a car, and that's a good question. So a car C, you can say like car C is A. And what this says is that C is this at character. On the other hand, here I'm saying S1 is the address of where the sequence HI exclamation point starts. Right? So if I were to put, maybe I'll put the @ sign here. For some reason it wants two text. One. Right. So C like an SO, and maybe I'll put so maybe in the variable table, I have my variable A, and that's set address 4000. And then I have my character C, and that's set address 3070. And then I have my S1, and S1 is a different kind of thing, right? So S1, it's the same kind of thing in the sense that it's still data. So in this particular case, it's 1032. The way we use it is if we want to print what you refer to as the string S1 is we go up to address 1032, and then we start printing out the characters in sequence until we encounter the special null character.
Does it make a difference which one you use?
Well, yeah, very much so, right? So so this is a string, so that means that it can be multiple characters in a sequence, and it'll print like everything up to now. Over here, like this is just in the same way that you can just have one integer, 10, whatever, 42. You can have one character, the @ sign. You can't have more. Okay. So that's a good point. So in general, so something like this is just not legal. And here it says that it's an error. So something like this. Also doesn't make sense. So if you want a sequence, the way you have to store the sequence is you have to just you have to put the null after, and you have to keep track in a variable, for example, S1, of the address of the first character. Right? So let's start from scratch and just do some examples. So I'll just define A and I'll initialize it to 42. I will not initialize B. I'll have S1 that's like that. I'll have a C that's like that. And I'll have a double that's like that. So this is not initialized and have any value. So that's legal, but can create problems. Because a lot of the time it would be 0 and you'd assume that's 0 always, but you can't rely on that. So S1 is of type car star. Okay, my computer died. So, okay. Oh. So right? So again, so here you can just print A, you can print whatever C, you can print D, so you print doubles using %F. It's a little bit annoying, but that's how it is. And you can print C using %C. So that's like that. And again, kind of if you mess it up, even in less interesting ways than giving something that's not an address and claiming it's a string. So you can, for example, say like the double is F and then give it something like A instead of C. Right? And A, we'll look above, is an integer. Right? So what's happening here? Well, it's kind of a prank, right? So like you're telling it, I'm going to give you a double, and instead you give it an int. So what's going to happen is, wait, did it refuse to do it? No, so it did it, and it decided that I'm just going to display whatever. So that's not even that's not even true. The problem is that you're basically giving it data that makes no sense and say interpret it as if I gave you a double, and that's just going to be a bug. So okay. So you can also, to answer a question from over here, you can directly store addresses in variables. So is address of A. So first of all, PA here is a variable of type int star. So PA stores an address of an int. And in this, and on the right-hand side, address of A is the address in the memory table where A is stored. Right? So that means that right now PA will store the address of A. And again, I'll print it. Like this. Comment all of this out. So control slash in / in VS Code. And now I'll get the address of A. So it's this much. So this is just the actual address in the memory table where the variable A in the function main lives. I can also get back to the value of A. So star PA is the value stored at the address PA. So I can say that the value of A is, and the value of A is of type integer. So I'll say %D. And here I'll say star PA. So what this is going to print is whatever is the value that's stored at this address. What is the value that's stored at this address? Well, it's the value of A. Yes.
Back to when you specified try to print A as a double.
Yeah.
So it didn't even print A.
No. Well, no. So in that case, so part of the issue is that doubles and ints don't take the same amount of space in the memory table. And like that would not necessarily be reproducible on your computer. Like it would just, like it's just the way to think about it is it's gonna do something that's not necessarily the right thing. All right. So, okay. So I'll set A to something like 34 here, and I'll run it again. So the address of A is this much, and then the value of A is 34. Of course, we could also get the value of A directly by printing it like this. That's the same, and that's the more straightforward way of doing this. Yes. Not on every computer. It's better to put LD. So yeah, that was a typo. So again, and the answer a lot of the time to questions like that about C, like what if you do not exactly the thing you're supposed to, but something different, is sometimes it might work, sometimes it might not. So the issue here is around like, why is D different from LD? Well, it's because it's going into the memory table and it's interpreting the data there as a particular type of data. And those types of data are not necessarily always consistent across different computers. So interpreting an address as a long decimal usually works, even though you see it's kind of like underlined a little bit there. The reason it's underlined is actually I'm also relying on what usually works, not what would always work. In this case, it doesn't matter very much because in practice, you don't actually need like the actual number that's the address of anything, except for demonstration purposes. All right. So this is like not easy stuff. So so addresses of are referred to as pointers. And that's like traditionally like the most difficult thing in first year programming. So we'll obviously kind of go back and forth on that a lot. So I'll just do a few more examples. So you can have a double and let's say X, and that's let's say 12.34. You can have, so usually I would do like P underscore X, but that's just a name. So I can say like underscore whatever address of var X, and I'll initialize it to address of X. So what that does is it takes wherever it decided to store X, and then it stores the address where it decided to store X in address of var X. And then you can say something like double Y is 25 plus star address of var X. And what this does is it's basically Y is 25 plus 20. Another thing you can do is you can say car S1 is equal to hello. And then you can say car C is equal to star S1. And what would that do? Well, S1 is the address where the H is stored. So what it'll do is it'll just go to S1 where H is stored, and this says, get me the value at address S1. The value at address S1 is H. right? Questions about this? So one thing to keep in mind is C, in a way that's unfortunate, uses the star in two different ways, right? So the way the star is used here so this is just like not an independent thing, it's just part of car star. S1 is a variable that's of type car star. On the other hand, over here, the star is used as what's called a dereferencing operator. So get the value at the given address. Right? So so they're the same thematically in the sense that both are dealing with pointers, both are dealing with addresses, but they're used in completely separate ways. Car star is a type that happens to incorporate the star. On the other hand, here star is an operator. It's an instruction. Go to address S1 and get me the value at S1. So completely separate. All right. Thank you very much. I shall see you on Monday. Bye. And labs start next week. So there's